Welcome back, Generals, to another Let's Fix Generals 0 Hour to make the best game ever. Last session, what did we do? We finalized this code here. Well, finalized in quotations. Next step, what do we need to do? We need to... We need to do some post-processing on the vtable stuff because we are missing some information. So, for example, we are missing names for the pure virtual functions, right? Here. Okay. Apart from that, what else are we missing? We probably need to know... let me think. We probably also need to make an association if a function belongs to a specific class. Right? So right now we don't have, where is it? Right now we don't have an association with function indices here. This is missing. And let's look at update module. Get updates. Snapshot. So we do. I hope that it will be enough. Let me search vtable for update module, right? Oops. This one. Right. There we go. Okay, so we know that we're mostly interested in these guys in the end, right? So it's this destructor here. We see it here. There's a destructor. Yeah. And then we have a public here, the CSC, xfer, and load post process. I don't know why they are called CSC snapshot here. There was a little bit of liberty taken in naming those functions, but the name should have been CRC and not CRC underscore snapshot, right? Yeah, it's a bit of a fail in Thyme that the names were not chosen according to what the original names are, but there was some loose renaming, which, yeah, then makes the names a little bit different. But okay, it still works as reference. Yeah, okay, so CSC xfer. And then we have here get update, it's this one here. And then we have, there's another one down here, get update phase. Why is this not showing here? Get update phase. It's up here. Why is it up here? Why is it not down here? So I would expect that this guy sits in between these two. But somehow it's up here. Why? It's not an override. Poof. The question is this correct or is this wrong? This. So the order of the virtual function needs to be exact. Maybe. Let me. Well, we'll probably get again a one-liner answer from Thompson's, which won't help us, but let me put it here anyway. Class update module. Is this virtual at the correct location? In vtable, it is lower. It is placed lower in the order. Placed lower. Maybe it's okay because it is not an override, but it's a new virtual function. Maybe that's why it doesn't matter much where we put it. Maybe. Maybe. Get update phase. Get update phase. Get disable types to process. Update module interface. Updates. So these two here, they refer to this. So there's a pure virtual here, updates, and then there's this one here. Yeah. Updates. Okay, and then we have behavior module, which belongs to this one here. And the behavior module also has object module and behavior module interface. And this one has module, and this one is memory pool object and snapshots. Oh boy. So there is a pure virtual and a virtual destructor. Then we have a snapshot. There's just a bunch of pure virtuals. Let me see. So there, here we have. Where are these from? Module. These ones. So there is a pure virtual here on object created, and then 3 more. Yeah. Then these guys. Yeah. Okay. And then on capture object module. Object module. Get stealth. On capture on disable edge. What? On capture on disabled edge. Where does this belong? Object module. Here. Ah, here. Okay. These two. Okay. Let's see. Then we have this here. Get updates. Okay. And then we have here get update phase. Get update phase is down here. Why is it down there? It's this one here. It's a virtual function that is created the first time in here. which returns a constant. Why is this down here? Why is this down there before this one? That's what I don't understand. Why is this down here? I don't understand the rule set of the order here. Like, I would have expected that this one comes behind this one. But it's not. And I don't know what to do with that. This one. It probably should be. It probably. The rest I understand. The rest probably makes sense. But this one. Get update phase. Is this put anywhere else here? Get update phase. No. 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 Get update phase. Get update phase. Get update phase. I don't know. Get update phase. Maybe we want to look at some other virtual table. Okay, how about we look at body module? Body module. Oh, we don't have it yet. Then we look at modal window. Modal, oops. Modal window. We got that. Okay, that's not helpful. Let's look at let's look at the vtable for archive file. Why not? Archive file. Okay. So here we have a bunch of pure virtuals. Oh well, that's not helpful. That's not helpful. Okay, how about AI site info? AI busy state. No. Wait state. No. Move Titan state. No. Thyme module. Okay. Okay. Input stream. Nope. Chunk input stream. Geometry info. I'm not really finding what I'm looking for here. What about radar? Radar. Yeah, okay. We have a bunch of pure virtuals here. Okay, maybe we can work with that. Okay, let's look at radar. Radar. There we go. Okay. So we have the CSC external load post process here. We don't have a virtual destructor. We do, but it's not here. It's here. Okay. Oh, this one doesn't have a virtual destructor. Look at that. But this one does. Okay. So, okay. Radar. So this one overrides the one in here. And then we have init reset update. Init reset update. Yeah. And then we have these here. These 6. Refresh terrain. Queue terrain refresh. And new map. Okay. Okay. And then we have these pure virtuals here. Yeah. Pure virtual. Okay, so I have an idea of where we're going, but yeah, I found it a bit strange on the update module that the one sits there in between. It's kind of weird. And here the ordering to me makes more sense, because it first overrides the stuff that is in here, right? So here, these 3 the firsts, which are part of snapshot, and that's the first base class. Then this one is the second base class, and this one has a virtual destructor. Yeah, so that's why we have here the virtual destructors. And then in there is the init, reset, and update is also part of the subsystem interface here. Init, reset, update. And there are 2 more, but we don't overwrite these, right? Actually, hold on. Load, post, process, load, and draw. Post, process, load, and draw. Why is this not listed here? Why are these 2 functions not part of this? Huh? Okay, that is confusing now. Post, process, load. Subsystem interface. Huh? vtable for this. Okay, let's search for this one. There's post, process, load, and draw, and the 3 pure virtuals, and a virtual destructor. Why? Okay, that's what I don't understand now. Why are these two functions not showing up in here in this list? Oh. They are showing up here. They're showing up here. Do we care? Maybe not. Maybe not. Yeah. Okay. Vitae. Okay, so here I think we need to change this to a string. And then here override. I think we don't need that. Okay. Okay, let's try to draft what we need to do. So So at the end, we need to do a post process vtables. Post process vtables. Yeah. Or let's say just process vtables. Okay. Then we create here a new function, void process vtables. Okay. How about we put this? Yeah, we put this here. Okay. So we are looking at how about we also need to process void process function class function process function class functions. There we go. Process class functions. Okay. Okay, I think the class functions, I think order doesn't matter much. Can do one or the other. So we are in parse function. Process class functions. Okay, so we call this guy. Okay. So in here, we need to associate all functions with classes, right? How do we do that? So we have functions. Let's say for function, and functions. And then we say function dot function Deckel context name, right? The context name for AB, this becomes AB. Okay, so for starters, that's actually a good question. Before we go on here, we need to know if we ever name a function with colons or not. Let me see. There's a chance that we do this because I've seen that in here we have a type info 4. Let's search for all occurrences. And here we have, well, let's ignore std here. Let's scroll down here. Here, here, OpenGL. So there is a class COpenGL, and inside we have some other classes. And here we have some weird type info. Okay. Okay, but it's only those. It's not too many classes. just a couple hundred classes. Okay, so here we have this colon thingy. So I think what this means is find or create class by name. Find or create class by name. Find or create class by name. I think we need to do a recursive call here. So we need to say if name dot find C++ string find substring finds. Okay, well, so std find, and we're looking for colon colon. But we're looking for the last occurrence. Hold on. We need to use rfind. Okay, so it size t. Okay, size t position. I'll find this thing, and then we say if pos is not std string npos, then name find or create. So we need to create a std string name copy name. Okay. Then we do it name copy. Okay. So if this pos is not an npos, then we do name copy dot erase 0. Oh, yeah, erase erase 0 and then pos plus 2, right? I think. Okay. So this should erase colons, but then we also need to call this recursively, find or create class by name for basically final class. Well, how do we know that this is a class, not a namespace? If it's a namespace, we don't want to call this. We will call function. Find or create. No. I think for our use case, we simply do how do we build this relationship to the parent class? How about we say our find name. How about we do a std string? Std string name copy, or name copy name const name copy equals name dot sub str with pos plus 2. There we go. Then we make it const, and then we do return return that name copy. There we go. Okay, this could work, but then how do we build a relationship? How about we say directory. Fine. Okay, how about we say index t, new class, or let's call it child class. Okay, child class index, and then here we return a child class index, and then we do const, and then we have const. How about we call this child name. There we go. And then we make a parent name with pos 0, pos 0 pos. And then we do parent class index, parent name. And then we do m classes child class index dot parent class index equals parent class index. And then we have m classes parent class index, and we put that to parents. Hold on, well, how do we know that this is find or create class by name? How do we know it's a class and not a namespace? We need to, I think we just need to parent name. We need to say if, m classes, m name to class m name to class index, okay, dot find parent name. There we go. But it's fine. Yeah, it's probably good for enough for now. Let's see. Find So it's iterator, IT class, parent class. Okay. Here we're saying to namespace index, parent namespace. So we say if parent class is not this dot end, then we do something. Otherwise, else if parent namespace is not this dot end, then we do something else. Okay. Okay, and here we say this IT parent class second. Okay. And here we would say parent namespace index is that. Okay. Okay. And then here we would also say classes IT parent class second dot child class indices dot pushback this guy. Okay. And here hold on, we have a parent classes. Here we would have a namespaces IT parent namespace second dot child indices dot pushback this one. Okay. Yeah. Okay, let's put a breakpoint in here. Yeah, let's see what happens. Ooh. Okay, so here we have OpenGL, C OpenGL, C color array. So there is a class inside the class, right? Good. Okay, so this looks good. The child name is C color array, and the parent name is C OpenGL, right? So we find or create class by name. All right. IT parent class is this C OpenGL. And then we have this one didn't find anything. So here. Sorry. So M classes, child class index is 35. Let's see. So 0x35. Yeah. So we're looking at parent class index. Okay. Parent class index. And here 36. 36. Oh. Right here. 34. OpenGL, and that one now is a child class index. Here. Okay. I think that's good. Yeah. Okay, let's see. We get some other hits here. C base VA. That should be the same stuff. Yeah. Okay. Then we have one more, another one, another one, another one, another, and another. Oh, are these like multiple ones? Chat. What's going on here? Child class indices. Now it has pushed back the same multiple times. Okay. Why? Why is it doing that? Huh. Why does it exist twice? I'm not sure why this exists multiple times. Find all current. So there's type info once and twice. It's twice. Why is this twice? That's what I don't understand. Ah, hold on. This one is for first executable. This is for the second. There's only one here. Why do we have this multiple times being called? I think because of base classes and so on. No? Let's see. Yeah. Right. How about we do it differently? Find or create. I think we should store it with the colons. Yeah, we should probably store it with the colons. What's the time? Parent. Find or create. Okay, how about we split this here into two functions? So we create a find class by name, and then we create a create class by name. Okay. Then we put that down here. Put that here. Okay. Then we put this here. Create class by name. There we go. And then we take this and then we put that here. Return invalid index. And then we say here. If not if index t index class index name if class index equals invalid index. Well, let's say if it's not, then return class index. Otherwise, or we say if it is invalid index, then class index equals create create class by name, and then return class index. Okay, and then we delete all this. And up here we say if We need to, what do we do? We need to say if class find or create class by name. Find or create class by name. If well, maybe we don't need this here, this split. What if we say this and this, and then here we say down here we say if we take this here, we say if we find this colon, then we do position, child name, parent name, parent name, parent name, and then we don't care about child name, parent name. Okay, we have index here, index. There we go, I put it here. There we go. Index. There we go. I think this will work. Let's remove these two functions again. And these two. I think this works. That looks simple enough. So we store it with the colons. Yeah, we store with the colons, but then we probably in the classes, okay, in the class, we probably need to have another here, std string view, and we say AAP, the entire name, function, base name, the base name, template arguments. How about we call it class base name? Class base name. Or just class name. A B becomes B. Okay. Class name. Okay. And then we say here child name. I think we simply say classes index dot base class name is equal class name I do wonder, is this actually safe here? This the string we're here and these ones here, are these actually safe? Because if this uses small string optimization, then this is not allocated, and then these may point to garbage, no? This looks not safe here to me. Maybe. Yeah, we may need to revisit that. Yeah. Okay, let's make this a string. Class name here, child name. So we say m classes index dot base class, no, m class name, there we go, is this name. Okay, parent name. Yeah. Okay, I think this will work. Let's see. Let's see. Okay, so basically this should now hit just a couple times here. There we go. So we have this C color array. Class name is C color array, yeah. Okay. And then here parent name is COpenGL, and this is found here. And then it will put this here, and it will put this as a child, right? So if you go to our watch here, then we see that this one now has one child here. Okay, so let's go to the next one. Here we have the next C-base VA parent name, okay. And now we have a second child here, okay. Perfect, next. All right, so here we have the next one, which is some other one, C normal array. Okay, this looks so far very good. Very good. Name. And here we have a std map, which is std namespace. Oh, this one is actually more complicated. Look at that bullshit. Because it has a template. Oof. 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 Okay, that one is a little bit more tricky. Not that we care much about STD, but yeah, that's a good question. I think we need to ignore everything inside smaller greater signs. How do we do that? I don't know. Ooh. Yeah. I don't know. There probably is a smart way to do this. I can't think of it right now. Okay, but I mean, at least for the other classes, it works. Yeah. How do we do it? Name. Our find. Our find. Let's ask ChatGPT. I have a string copy value. I have a string. How can I delete everything inside? How can I would like to search this string I would like to search the string but exclude everything inside this from the search. How do we do that in C++? Let's see. Finite state. Search ignoring brackets. What? Jesus Christ. Start ignoring, stop ignoring. What? Search ignoring brackets. Search ignoring brackets. Filtered. Oh, so it makes a copy of the string. Okay. Okay. Yeah. I mean, in that case, you might as well just do it another way. We do const size t pos equals name dot r no dot find. So we find the first this symbol, yeah, and then we do r find. And r find, can we put a position? R find. Let's call it limit. And then r find, can we do a limit? No. R find. I think we do a name dot sub str, and then we say 0 limit r find, and then this. I think that's a much simpler algorithm, at least much simpler to write. Okay, let's see if that works. Okay. Okay. Okay, so we have limits. Okay, so name. Let's put the breakpoint here. There we go. Okay, so limit position. C base VR parent name. Okay. Okay. Limits. Okay, let's go to the map. To the map name. Clump. Simple object iterator clump. Okay. Clump. Parent name C simple object iterator. Okay. 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 We have a bunch of these guys. Okay. Parent name. Okay. Model array class. Okay. Okay. Okay, well, what happened to the STD map now? What happened to that? Where's that? It would have gone, hold on, yeah. Let's put the breakpoint here. It's, yeah, because we didn't create a namespace for it. That's why. Okay, let's do it again. This, yeah. All right. Okay, there we go. There's the map. Limit is name find. Okay, this, and then the pos is 3. So now the class name is this. Okay, this looks good. And the parent name is std. Okay, this is correct. And then it won't find a class, but it also doesn't find a namespace. So we probably would need to create a namespace. Yeah. Okay, how about we create a new function, namespaces. Here we do index t find or create namespace by name. There we go. Okay. Then we create a copy of this guy, and then we put that here, and then we put namespace, name to namespace. There we go, name. Put here namespace type. There we go. Namespaces. There we go. Index namespaces. Okay, enums. Classes, functions. Okay, namespace, name, index, blah, 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 blah. Okay, I hope it's everything good. And then we say here, if this is not, if this else, I think what we can do is else index t namespace index find or create namespace by name, and we say parent name, okay, const, and then here we put this find or create and push back that namespaces. Hold on, that is wrong. Index that. Okay, then we remove this one here. And we say here else. There we go. Okay, I think this is correct now. Let's double check that. Now this may only work with one level of parent, but that seems to be the only occurrences we have, so we don't care about multi-parents. That would probably require additional fixes for multi-parents. Yeah, but we don't have this. It's only ever one parent from what I've seen, so this is probably fine for what we need. Don't need to over-engineer it then, right? Okay, so this works. We have a parent class. Okay, and here namespace. Let's put a breakpoint in here. Let's put a here. Okay, so it's std. It's a parent name. Yeah. So we create this namespace. Yeah, it's a first namespace and probably the only one, which makes things simple. Okay, parent namespace index. 0, and here namespace class has this one in this class 125 hex. Okay, cool. Then we have built that relationship. Then let's put some more breakpoints here. So this is breakpoint simple object iterator, camera shake system class. Oh, camera shake system class. Oh, here we have a problem. Here we have a problem. Because we have the camera shaker class. Camera shaker class. Camera shaker class, so it's here, but then we have this one here. Where's this? Oh boy, type info for. Huh? Camera shake system class. Why is there no type info for this guy? What is this? It is a class. Which contains another class. But somehow camera shake system class. Camera shake. Type info for. So we have this one, but we don't have the other. There's this one here. Camera shaker system. Camera shake system class. Let's search for all occurrences. There's a V table. Camera shaker class. Okay, let's camera shake system class. Maybe we need to create classes from functions, because not every function has a type info, and not every class has a type info thingy, RTTI symbol. That could be, yeah. Interesting. Okay. But we know that this class exists because we do have functions for it, right? Here. So we know it's there. But we don't have a type info for it. That's interesting. So what we also need is we need to oh boy here in between these two I think we need to have another here generate classes from functions. Probably need to do that. Void generate classes from functions. It generates classes from functions because not all classes have type info, have RTTI. Okay. Okay, let's do that then. Generate this, yeah. Okay. Then create this function here. Oh, I don't know where I move this, right, okay. Okay. Okay, then yeah, then this should be solved once we have the class. Yeah, okay. Good, but I think that is good progress. We have learned something and we are slowly advancing. Slowly advancing. Okay, then, yeah, we leave the breakpoints here for now, for the next session. So we need to implement this first. Yeah, we slowly move forward here. It's quite complicated and quite intricate, but it's coming along. It's coming along. Oh boy. Good. Oh boy. Good. Then let's see if it compiles. Yes. Okay. Good. Then I will take a break here. It has been almost 2 hours. Yeah. The next session we will implement this function, and then hopefully this will prevent creating wrong namespaces. I think there should only be one namespace, and that is std, nothing else. I don't even know why std class is in there to begin with, but that's okay. Yeah, so yeah, it looks like some classes we need to generate from functions, which is not a problem. Yeah. Okay, good. I'm happy with the progress so far, even though it's still not so much fun. But we are in the flow right now, so it's not bad. It's not too bad. It has been worse at the start where we literally had no idea what to do, and now we have a little bit of an idea what to do. That's good. All right, and we're slowly chipping and advancing. That's good. All right, then I will take a break here. Let's see what he wrote. If it's first time, then order matters. If it's an overload, doesn't matter. It's first time. It is first time. But there are overrides around it. I'm not sure if position is okay by chance, but it does not strictly match order in vtable, and it confuses me. Okay. Good. Then I will take a break here. I wish you a great day or night. Until next time, goodbye.